Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, peace be upon you. First of all, let's give praise and gratitude to God the Almighty, Allah Subhanahu wa Ta'ala, who has given us mercies and blessings so we can be present here in perfect health amid the current COVID-19 pandemic. My name is Gama Harta, your moderator. I would like to welcome all of you on behalf of the committee to this international webinar on green innovation. We are so delighted for having all of you today. Dear all participants, this webinar is held by Faculty of Engineering, Pancasila University, as the second occasion of its 5 webinar series. This webinar will focus on trend in green technology innovations. We are sure that this topic is highly important for all of us, as we know that the attention toward green innovation as well as sustainability has been growing recently since our beloved Earth or environment, either the air, land, or sea, has become more and more suffering day by day, all around the globe, as a result of our profit-oriented actions, which has somehow neglected the environment. In this connection, we all should show our responsibility, whatsoever our role in the society, especially we as academia, to improve the quality of our environment by doing some innovations, for sure, to overcome such the issue. Well, at this time, we would like to have a presentation from our distinguished speaker, Professor Ralph Forster. Professor Ralph Forster is currently the head of Production Engineering Laboratory in Boyd Hogeschool voor Techniek, also known as Boyd University of Applied Sciences in Berlin, Germany. He is also visiting professor for several universities such as Pancasila University itself, Institute of National Science and Technology, and German Chinese University of Hefei, China. His research fields include electro-discharge machining, electrochemical machining, micro-machining such as EDM and ECM, machining ceramics and glass, friction welding of bamboo and wood. Well, the latter research field is for sure closely related to our topic today. Professor Foster will deliver a presentation entitled Trends in Research of Sustainable Materials. He will highlight his research in using some alternative materials, especially the bamboo, and in application of joining technology. This effort is part of our responsibility to answer the green innovation challenge. Okay, ladies and gentlemen, before we begin the presentation, I would like to inform you that this session will be divided into 2 sections, the presentation section and the question and answer section. For the Q&A section, you are allowed to ask for questions using the chat feature. So during the presentation, you can write down your questions there. And to get me easier to find your question, please start your question with a hashtag symbol, followed by the capital letter Q, that means question. Okay? And also, I would like also to inform that the presence link will be sent via chat room during the session. So don't forget to miss it, don't forget to miss it and fill it out. And since the certificate link will also be sent via chat room soon after the closing of the webinar, Therefore, I hope you don't leave this webinar first before filling out the presence form and downloading your own certificate. Well, without further ado, I would like to welcome Professor Ralph Forster to deliver his presentation for the next 45 minutes. All right, Prof, please.
All right. I will share my screen. I hope, you can see my screen and you will hear me very well.
Okay, good. Yes, we can see it clearly, Prof.
Okay, that's great. Okay, selamat siang. Very warm welcome from Berlin. Our weather is a little bit cloudy, but no rain, and we are happy that we don't have any coronaviruses. I hope the same of all my auditorium. I hope you will stay healthy in future, you and your families. And now I will start my presentation about our last trends in research of sustainable materials. I guess a lot of you know the first overview slides about our topics, about the application of friction welding, different sandwich materials, about our research in bamboo, wood and sustainable materials. Okay, as you know, the world population is growing very strong. We see in Africa and Asia a lot of peoples. All these people want share the same living standard like the Europeans. On the one hand, on the other hand, we try to protect our nature and the environment. Nobody of us can live without nature. Everybody wants to increase the living standard. We need to reduce the pollution, the waste, and we must protect our nature and the environment. If we can use reusable materials, sustainable materials, we must collect a lot of knowledge about the material properties, about behavior during the life cycle of our devices, of our products. We try to developed compound materials, and we must collect some knowledge and some experience about the interaction of different materials when we try to use the advantages of new developed materials, and we have to increase our knowledge and our skills, of course. So we need other construction materials. We need some alternative building materials, as you know, in the sand for mixing concrete to building beton is decreasing. The prices for this material is increasing very fast. One of our alternatives are wood. In Europe, well known as a material for houses, for devices, and so on. Everybody knows this. In Asia, there's well-known bamboo as a traditional material with very interesting material properties. But we need some new technologies for use bamboo, like joining technologies and so on. And we have investigated in the last year the friction welding process on bamboo and wood too. and I will tell you something about our results and something about our ideas of new materials. Yes, all of you know bamboo much more better than the Europeans. The structure of bamboo is similar to wood, and the basic properties are also similar, but bamboo is a member of the grass family. It's not a wood, it's a grass. And there is a hard outside and a soft inside. It's very tear resistant fiber stands, and most bamboos are divided by knots, and the tensile strength of the bamboo grass reach values up to 14 kilonewton per square centimeters. The main content of bamboo is cellulose and lignin. This is also similar to wood. Very interesting and very important for the connection of bamboo with the friction welding process is the content of lignin. The content height of lignin in the bamboo plant is similar to wood, and that's why we can use the experience in friction welding of bamboo also for the friction welding of wood. So here are different pictures, cross-section of bamboo, of different bamboo types. You know, there are a lot of different types and a lot of variety of bamboo. Here are the knots. It's a cross-section of a bamboo stem with the knots and the hard outside and the empty inside with very stiff knots. So, what are other sustainable, very interesting biomaterials like coconut husk, banana stem, and so on, banana ropes, palm tree fibers? Those are biofibers. These are very interesting for the next step for outside material of sandwich materials, lightweight sandwich materials, like hemp fibers, like linen fibers, and so on. There are a lot of ideas and opportunities to use such materials from a bamboo system. We have some properties of such sustainable materials like linen, also for hemp. These are very often used in Germany or in Europe for ropes, for clothes, for pillows, and so on. But there are no so many applications in with a technical background, with an industrial background. But the advantage of the biomaterials are they don't have, after using, with the end of using, no hazardous waste. They have no influence of the, also no negative influence of the environment, and we can use it independent of our Earth. So, but we don't have such standard values. We don't know the properties of the Asian biomaterial, like banana trees, like coconut fibers, and so on. And that's why we have to do a lot of research with these materials. The last year was the year of Corona, and we don't have had the chance to exchange our knowledge. We don't have the chance to travel to Indonesia to get some more informations about the Asian fibers and so on, but I guess in the next year we can cooperate together and we can try to find out more properties and can increase our research in this topic. So what we have done in the last year, we have installed a cooperation with a niche company. They are a developer of special material testing machines. We have different chambers. We can adjust the chamber temperature between minus 160 degrees up to 500 plus 500 degrees. We can measure different deformations of this. We can adjust the moisture and so on, and we can collect a lot of data. Depends on the temperature, depends on the water content of our material, and so we can do a lot for collecting the basic knowledge about the behavior of our biomaterials for new applications. Here are some tests which we have carried out with hemp fiber. We have a constant temperature of 24 degrees and the constant humidity of 20%, and with a time sweep which increased stepwise the humidity, and the temperature sweeps between 20 and 18 degrees at two constant humidity values of 13% humidity and 60% humidity. So that we can collect first data with hemp fibers. Actually, we are trying to install new clamping systems for measuring really single fibers, very thin single fibers of our material, and we have seen how the behavior is changing during the time. Here are also some results with different humidity values and what happens with the stiffness of our material. Here are some other results about tension. Depends on the this different static loads and dynamic loads at a fixed temperature and with a continuously increasing humidity. Oh, here are some other results. These are also results from one single hemp fiber, but for the future we must collect much more values for different materials and with different testing environmental conditions. Yeah, some others. What is a main problem of our research are the connection. Here are some traditional connection systems of bamboo and wood. We can join this with some ropes, with seals. We have metallic joinings. We can connect it with some bands and so on, like fibers, like thicker fibers and so on. But the demands for joining technologies are this connection should be free of chemical glue. It should be sustainable. We want have hazardous waste, and the connection should be reproducible. Here can you see the traditional friction welding process of a metallic shaft. As you can see, at the first step we have two metallic cylinders. Then one of our cylinders is fixed and the other part of our sample is turning, and with a high pressure force, temperature is increasing. We can reach the melting point, and we can get a very stiff connection between these two parts. After turning, we don't see any differences in our surface, and we have a very nice cylinder, a very nice shaft. This is a standard technology for friction welding. Yes, it is. As you know, the Germans like it to make tables, to make standards and so on, and also the friction welding process has own standard. We have the welding through movement. This means there is no external heat. There is no flame, no plasma, nothing. We have an ultrasonic welding. We have some sonotrodes in this ultrasonic welding. This is very often used at the electronic industry, at the semiconductor industry, like ball bonding, like ultrasonic bonding, if you want to connect the very thin wire of integrated circuits with the outside plating. This ultrasonic welding is used, I guess, in 99% of all connection processes, joining process in the semiconductor industry, and we have also an ultrasonic welding process in the packaging system. If we cover some very sensible devices, electronic devices with some sheets of plastics and so on. The connection is very often, for the connection process is very often used also an ultrasonic welding process with an sonotrode. Then on the other side we have a friction welding process. This means we are using the friction between two parts for initiation of a very high temperature, for initiation in high energy content, and then we have an vibration friction welding. That means that our pieces are moving against each other, and then we can, if you take your hands and put your hands together, then you can feeling also the thermal behavior of the friction, and this thermal energy will be used for the heating and warming of the surface, and then we get also a stable connection of two pieces. Like the linear welding process, that means we have only a linear movement, or the angle welding process. That means we are turning the both parts against each other, and then we have the same effect. And our topic are the rotational friction welding process. That means one of our pieces is fixed and the other is turned.
Geser aja, semua tuh digeser tuh, stop. Nah.
Iya.
There are any questions? Hello? If there are any questions, you can ask me.
I think it was
Noin.
only a noise.
Okay, it was ordinary. Oh, I'm so sorry. Okay, and this is what we are doing. We are have one fixed part and the other rotated part with a pressure forced for the connection. Here, these are some cross section of linear friction welding of wood. This is real beech wood, and here can you see also the debris outside of our welded zone, the thermal influence zone, and there's also an friction welding process for a cylindrical connection joint in one borehole. What can we see when we have a cross section and look inside of our friction welding zone? We have a compacted cell structure on the top, and down we have also a compacted cell structure, and in the middle where is our connection, we have pyrolyzed mass. That means it's a mixture of carbon, a mixture of lignin, which is used as a natural glue, something like that. After high temperature without burning, we have natural glue, a sustainable glue, which is used for the connection of our different wood or bambus types. Some advantages of friction welding of wood and bamboo are the connection can be established quickly within a few seconds. We don't use some additives. We can combine different wood and different bamboo materials. We can adapt different type of wood, a different type of bamboo for the combination of different behavior and for different applications. We don't have any curing times compared to some used glues. And the complete product is only made of wood or of bamboo without any additional materials, and that's why is it really easy to recycle. We can put it on the earth and wait some years, and we have also earth, or we can take it to a fire and we can eat some satay or whatever. We can use it like standard wood materials, like standard wood products, without any influence of our environment. So, 3 years ago, I have, 2 years ago, I have shown you our first initial test. 2018, we tested pine and beech with our standard turning machine. I hope you will remember what we have done. I will show you our first videos about this. I hope you can see the video.
Yes, we can see, Prof.
Okay, that's great. That was our first test equipment. It's a standard turning machine. It was very easy to use. It was a fast start, but the first steps was really successful. So this was wood video. Here is a same procedure, same process with bamboo in it's a lathe. We need a special clamping system for the bamboo material, but it works very well. So, and as you know, it works also in Indonesia. We carried out the same similar test at the Pancasila University with original bamboo from Indonesia, and as you can see, it works in Indonesia very well too. And we have get the same results, and of course in Indonesia we have bamboo with a thicker diameter, and then we have also a higher stiffness and so on. And as you can see, it worked in Indonesia in the same way like in Germany. That's great. Huh? That was our first steps 2 years ago, and we carried out a lot of tests about the welding time, the welding pressure, the path length, the speed rate, and so on. 3-point bending test, you know all this, but the big advantage is I get the funding from the German government together with an industrial company to build up a special adapted friction welding machine, especially for wood and bamboo too. Here's a short look inside the machine. This is our clamping system for the rotational part. Here is the clamping system for the fixed part. Yes, here is a different view. This is our turning part, and here this is a fixed part of our product, and then we can combine this, and we have make a lot of tests, as you can see here in the video. This very hairy arm is my arm. And we can adjust the pressure time. The system stops very fast. We can adjust different after pressing times, and so on. We can adjust the rotational speed and so on. And as you can see, it's stiff and hard. Of course, not each test works well. Here's one of our failure videos. Not each project in Germany is a successful project, and not each test is a successful test. As you can see, nothing happens. Huh? No smoke, no temperature. There's nothing. The problem is the friction on this both parts of the clamping system was not enough, and that's why we put it through the clamping system. Okay. These are our new equipment. It's we get it 1 year. 1 year ago. That was finished, and since this time we carried out a lot of tests and a lot of new. We create a lot of new results, and we have increased our knowledge about the process. This is our testing equipment for the tensile strength test. Yes, it's a standard system of the Zigro company. Here are some results of the tensile strengths of pine. Here the tensile strengths, and here are different sample with different test parameters. Yes, and as you can see, we have a strong influence of the testing parameters. Of course, we could identify the best parameters for the pine and also for beech wood. What is a very interesting result, we have different results depends of the thickness of the width of the annual ring of wood. This is not independent from the structure of the wood. That's a very interesting result that we have an influence of the inner structure depend on the ring width in the wood structure. So here can you see? Also here is a pine, and as you can see, these are the different wood annual rings at the wood structure, and this is also like a gluing connection, like a additional joining connection. And at the pine, it's in most of all samples, it's a problem, it's influence of the pine wood. When we have a look to the beech wood, we don't see such behavior. That's a really different difference of the wood material, and as you can see, the tensile strength of pine is 2 times higher than of beech. What was another effect? We have tried to test the hardness of the single annual rings, and that was really interesting. We have an early wood. This is much more softer than the late wood, and you can imagine that we have different friction properties, different pressure forces on this material. This is a piece of one natural growth up beech wood with such really different hardness values. This is hardness of Brunel, and here are also the diameters of the beech compared to the early wood and to the late wood. In Germany, sometimes it's called also summer and winter wood. That's, I don't know, maybe there are similar similar behavior in Asia, Indonesia, but I'm not sure about this. But this is really interesting result that we have seen such an influence. So okay, here are some pictures with an thermography camera. We need temperature in the range of 300 degrees, and we could see this with an infrared camera. And we have also a computer tomography system, and here can you see the welding area. And here is are the different wood types, the different wood structures. These are similar of the different density of the annual rings in the structure, and that's why we can find a different behavior. As you can see, this is also in a picture, and you can see the borehole inside in the middle of our test equipment, and how it works and how it connects in this welding zone area. Here, similar different sample. It's a sample 3, and here are similar welding zones. It's comparable to the other pictures, but the structure of the ground material is a little bit different. Okay, what we done too. We compared the friction, the tensile strength which we reach with an friction welding. The average value was 3.3 megapascal. And when we are using different glues like Ponal-X press after 8 minutes, after 13 hours, Ponal water glue, and also Otto color. These are German trade names. I guess I brought 1 year ago similar glues to Panchasil, and you can use this glue too, so that we have with a friction welding process not the same values, but 50% of this values without any additional chemicals, without any hazard materials, and this is a value which is acceptable for the wood industry, for the skilled workers and so on, and our cooperation partner says, okay, that's fine, we can work with such a process. Okay, I guess my time is over. I have 40 sheets more. In my opinion, I should prepare a lecture for 2 hours, but I guess your plannings was a little bit different. We can interrupt here, and you can ask me some questions. We can discuss about the results, whatever you want. It's your decision.
Okay. Okay, thank you so much, Prof. Foster, for your informative and interesting presentation that you have shared with all of us. I think there are a lot of things that we can highlight here related to our theme, the green innovation. We can see that as our environmental, the environmental degradation progresses, the replacement of materials must be done toward more sustainable or eco-friendly materials such as wood, bamboo, or other biomaterials. As like what you already shared with all of us, there are a lot of biomaterials that we can select or we can use as the substitutes for dominant material like metal, for example. There are a lot of materials like coconut husk or banana stem, hemp fibers, linen fibers, and etc. All of them can reduce waste and pollution. And we can find other highlighted information from professor's presentation. The material properties as like bamboo, as described, has supported our view, that there are a lot of alternatives that can we exploit, to support our view regarding the green innovation. And there is also some related technologies that are available, yeah, to be applied for such the purpose. All right, all participants. Now we come to the Q&A section. I will find your questions in the chat room and read them all for Professor to get response. Well, the first question coming from Mr. Arif. His question is, how many types of bamboo have you ever studied so far?
Actually, in bamboo we have only two types studied. Our main problem is we cannot travel to Indonesia, and I cannot bring more bamboo types to Europe. We cannot carry out this research in Indonesia. We have used only two bamboo types in Berlin. In Berlin, we have some samples of bamboo. We have, I guess, 7 different bamboo types, but we don't have enough bamboo material for carried out such standard tests. That's not enough. I hope after finishing the Corona crisis, we can get more Indonesian students at Berlin, and we can also send some German students to Indonesia again, and then we can carry out much more bamboo testing. Now we have a problem of material, and as you can see, our bamboo material, this is only the very thin bamboo material, and I guess this is not comparable with wide variety of the diameter and the wide variety of different bamboo types in Indonesia.
Okay. Thank you so much, Bro, for your answer. Hope it answer your question, Mr. Arif. Next question is coming from Mr. Ade Najuri. Okay. I think he has 4 questions for you, Prof. Okay, I will read the first question first. Okay. What is the standard reference for the application of this kind of material and testing?
Depends on the test. If we have also carried out 3-point bending tests, different tensile stacks. Depends on the test. In Germany, we have a lot of standards. I will try to find some examples. The
Udah kan saya?
Yeah, as I'm searching some. Sorry, I cannot find. We have different standards, like 3-point bending test, tensile test, and so on, like hardness tests. I'm so sorry. I can't. I can send you some test standards.
Okay, Prof, we can proceed.
Yeah, that's a standard test which describes in German in industrial norms, in industrial standards.
Okay, Prof, we can proceed with his next question.
Yeah, okay, I guess it's better.
Okay, his second question is, what is the biggest challenge in producing or manufacturing the component or part using such kind of materials?
The main problem is to find out the medium values and to calculate this structures because the material are naturally grown with some mistakes, with some interruptions, with some fiber breaks and so on. And as you know, each material which is growth up naturally is adapted to the environment. Some woods, if they get in the use a lot of storm and hurricanes, are bended and so on, and that's why it's the main problem to describe the behavior in a way that later it can be calculated very well and safe.
Okay. Yes, sir. The third question is, what is the current research trend in Germany, and what is the next 5 years for the trend? And yeah, I think it's enough here for the question.
I guess the main trends are lightweight structures with wooden components or with biomaterial components. We are starting now a cooperation with some architectures and engineering offices for development wooden sandwich materials for building skyscrapers. We built up actually houses with 4 levels, but a lot of them are interested in to build up higher houses, and also our last discussion 3 months ago was to create some ideas for the development of wall elements for the fast installation of emergency hospitals against coronaviruses. That's an idea, or that's a demand. That's a lot of German companies want build up mobile hospitals for the fighting against corona.
Okay, yeah, that's right. Well, sir, the last question from Mr. Ade Najuri. How can we Indonesians be involved in the research? What qualification should we have?
you should be a successful engineer. You should be a bachelor of engineering, something like that, or of material science, mechanical engineering, whatever. And then we can cooperate together. We can carried out a lot of tests for the behavior of biomaterials. As you have seen, we don't have enough knowledge about the behavior, about the material properties of a lot of very, very interesting biomaterials in Asia and especially in Southeast Asia. And then we can cooperate in a very, very wide variety of different projects.
Yeah. Okay, thank you.
Take your Tensile strange testing machine. Take some laces and carry out the same tests like we in Germany, and make tests with your bamboo, with your jati, with all your kind of woodens what you have. Make tests with banana fibers, with coconut fibers, with palm oil tree fibers, whatever you want.
Okay.
They are topics for 100 of bachelor, master and PhD theses.
I don't know, sir. Okay, I hope your answers satisfy Mr. Ade. Okay. Okay. We go to the next question, Prof, from Mr. Dennis Audrey from Pancasila University. He said, I would like to ask, since the COVID-19 outbreak, I have attended many seminars on energy, and I know that Indonesia has developed technology toward low carbon and renewable energy technologies. There have been many products resulted from the implementation of the technology, which are unfortunately have not been widely published to the public. The question is whether the impact of the technology trend that we are working on has a good effect. Why are they so rarely reported? I think it is the summary of his question. Why are the reports of these renewable energy technologies and its application rarely reported? Can you get my question? My statement?
Yeah, I'm sorry, I don't understood the question very well. The problem is the report of the report of some research results, or what is I don't find out the problem.
I think it is related to the publication of the application of technology or the products resulted from the application of the technology, something like that, Prof.
I guess we have after research and after find out some green technology, some green engineering and energy saving technology, we must try to find applications for this. And in Germany there are some pioneers, some first user. They are building up the first solar roofs. That means roofs which are equipped with solar cells, and then they are producing energy from the sun. And 24 years ago, I guess the situation in Germany was similar, and some private persons starts their own private projects, and maybe there's a similar situation in Indonesia, that the Indonesian people needs some projects like a lighthouse, something that I hope that was answer of the questions, but I'm not sure.
Okay. Okay, Prof. Maybe if I can add his question, is it for example, nowadays why people understand that the using of materials that are not eco-friendly or good for environment, they still keep using the materials. Yeah, it's like plastic. We know that the 11% of plastic usage has destroyed our sea. Okay, and let alone the rest of it, 89% has destroyed our land. Okay, but people know it, but why they keep using it instead of shifting to the renewable material or sustainable materials, it's like wood or bamboos or biomaterials. And is this because of the rare publication of this founding, for example, this fundings or this
Okay.
innovation?
Now I get that's it's the first step. It's a question of the price, of the costs, of course. In when you go in Jakarta to a market and want drink some juice or something like that, you get very often the juice inside a plastic bag.
Yeah.
Huh? That's a standard. That's the cheapest wrapping packaging system for the people, and you have a very huge part of very poor peoples, and they cannot pay for an glass and so on, or for a cup and so on. The investment, if you have an street food market, if you are a merchant of a street food market, you must invest, I don't know, millions of rupiah for glasses, for cups, and so on, and you can't do this. Yeah, that's a very often a problem of the price, and to fill some liquids in a plastic bottle, it's in the first step it's much more cheaper than to fill the liquids, the drinks in a glass bottle, and so on. If you want using glass bottles, you must install a recycling system and then closed recycling system of producing the bottles, filling, washing, also cleaning, washing, desinfection and refilling and so on. And this all are very cost intensive. And that's why it's the first steps of protection the environmental are very expensive. The costs of destroying the nature must be paid later than the first costs of installing some recycling systems, some biomaterial systems, and so on. And oil is cheap. Compared to some other materials, is oil a very cheap base material.
Okay, Prof. Before we go to the next question, I would like to inform you that our distinguished Dean of Faculty of Engineering, Professor Dr. Budi Suyitno, has sent you greetings.
Thank you very much. I send the best greetings from Berlin back to Jakarta and to my friend, the deep Prof. Budi.
Thank you so much, Prof. Okay, our next question coming from he asked, is it possible to breed a new kind of smaller type or smaller size of bamboo with good tensile strength, or that will be possibly enhance the properties of bamboo fiber for specific applications?
I hope so. I'm sometimes a scientist, and I believe in science, and I hope we will develop a lot of helpful and senseful things. I hope if we are cooperate together and mix our knowledge, we can develop everything. I hope so.
Okay, hope it answer your question, Mr. Singgi. Well, I would like to welcome our Dean, Dr. Budi Suyitno. Maybe you would like to deliver some statements. We welcome you, our Dean, please.
Yeah. Thank you very much. Good morning, Professor Foster.
Good morning. Selamat siang to Jakarta.
Yeah, guten Tag.
Okay, perfect. Your German is much more better than my Bahasa.
Thank and pleased to be with the creative Professor. It is really.
I'm so sorry. I don't have any tone. I cannot hear your voice.
Yeah, Pak Budi, your voice is not clear here. Could you please fix the?
Oh, okay. Okay, maybe it is.
Well, while waiting for
Yeah. Okay. Yeah. Prof. Foster, it's really a great honor for me to be here in such important event that you have participated in as a great lecturer, and also honor for me to have a good time during your presentation. It is really a pleasure hearing your recently innovative product or research. I
Thank you very
appreciate,
much.
yeah, your I appreciate your presentation indeed, and hopefully in the near future I will share about our research recently.
Yeah.
Again, thank you very much for your support and also your participation in this webinar. Thank you. Guten Tag.
Thank you very much. Thank you. It's my pleasure to cooperate with Panchasila.
Okay, thank you, Mr. Dean. Now, okay, we can continue to the next question. This is question from Rohmat Andri as the fifth question. As we know that the major disadvantage of bamboo is its poor resistance to fungi and bacteria, and it is sensitive to get attacked from insects. Um, so, can you share about more knowledge or innovation to overcome this shortcoming of the bamboo material? Please, Prof.
Okay, it's depends. Um, what we have seen in Indonesia, some bamboo materials are very resist against insects and fungi. Depends on the preparation before. Some people told me you must bring the bamboo for more than 1 year into water, and then you have long life stability of this material. The other opportunity is to change the wood. That means using bamboo in Europe, because we don't have the same insects which are adapted to using bamboo as an insect food, and you can get German woods or German materials for Indonesia. That's depends on different properties, and of course there is wide variety of research needed to improve the life cycle of natural based materials.
Okay, Prof. Now we have next question from, sorry. I think he didn't mention his own name. The question is, the bamboo offers structural tensile strength and can be used to support weight over long spans. Do you think can bamboo replace the use of steel due to its tensile properties?
Yes, of course, and you if you build a cross laminated timer made from bamboo, you can produce a lot of huge devices for reducing some steel construction. Yes, it is in Germany, we have a huge industrial office and industrial roofs where the mainframe is made by wood. Cross laminated timber. You can produce also cross laminated bamboo. Yeah, I can maybe I will find COT picture. I will have look. Yes. Oh. Can you see my picture? My screen? This picture?
Yes, clearly.
This is typical CLT cross-laminated timber materials, which is much more lighter than steel, but with the same stiffness. And there are a lot of industrial applications for very huge. In here, something like that. I know some devices with a length more than 18 in the range of 18 meters, and then you can produce a lot of here something like that. Oh, sorry, you have seen here. Can you see this? CLT panels. These are similar to an airport hall, something like that. And you can use such an CLT also. Also, you should call this CLB, cross-laminated bamboo, and then you can use this in the same way. You will not use the rough bamboo material. You must use some CLT materials, something like this. This should be a standard process, and you can install such fabrication also in Indonesia, I guess. Okay.
Okay, Prof. I think since the time is already over, I think it's time for all of us to close this webinar. Yeah. Okay, but before we close this webinar session, I would like to remind you to fill out the presence form and also to download your own certificate as the link has been sent to the chat room. Okay, we also ask your kindness to join in our photo session. So please kindly turn on your camera. Okay, while waiting for all the participants turning on their camera, I would like to remind you that our next webinar series, the third webinar, will also be held in the next November, the 17th, on the theme of green energy for Indonesia. Hopefully, we will see you there. Okay, Professor Rafoster, could you please? Oh, sorry. Okay, we will take a picture from the first page. Sudah semua? Okay. Okay, we already got the photo, the pics of all of us. Well, now it is time for me to close the webinar. We would like to say thanks again to Professor Foster for your informative and interesting talk, and also to all the audience for your attention and active participation. We also apologize for our shortcomings and for any inconvenience caused during this occasion. Hopefully, this webinar will be beneficial for everybody, all of us. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Bye.
Thank you. Bye.
Thank you. Bye.
Bye.
Thank you. Thank you.
Thank you,
Thank you, sir.
Prof. Foster. See
Thank
you
you.
next time.
Yes, of course. I hope so. after Corona. all we are praying for finishing the Corona catastrophe.
Thank you very much. Thank you, Silva.
Danke, Prof. Und auf Wiedersehen.
Auf Wiedersehen. Selamat jalan.
Dankeschön, Prof. Bye.
Thank you,
Bye.
Professor. It's been an enlightening session.
You're welcome.
Danke, gut.
Okay, bye.
Terima kasih Pak.
Thank you, Prof.